I'm Stan Moote, and as you mentioned, CTO of IABM, and we got a great panel lined up here, and I think we're going to have some fun and keep it interactive. I'll keep an eye on the chat box if you want to ping me. I don't think there's any issue to open up your microphone once we get going, but just ping me there with a question or two. We can go one way or the other once we get going. For the first little bit, I will ignore it though. And I'm going to actually start off with my buddy John here, Mailhot, and you've been super deep into the standard side of 2110 and recommendation TR03, and I guess 04 for that matter, that led into 2110. So certainly the focus was clearly studio quality audio and video. Let's not forget about audio in this discussion today. So tell me what's going on with 2110 and the cloud.
Well, I mean, those are two questions that aren't necessarily the same question, right? So 2110.
That's the point of the discussion.
Yes. So 2110, you know, it's a topic that started in you know, the last 2000, I don't know what, 2012, maybe 2011, somewhere in there. As, okay, what's the logical replacement for SDI in the situations where we use SDI? So that was really the motivation, was to figure out how do we migrate away from the proprietary technologies and move on to the, you know, platforming of the IT industry, but in the context of fairly traditional rest of television. And so I think that really was the lens that we thought about 2110 through, is how do we get unapologetic studio quality, pixel perfect, blah, 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 you know, because SDI had some virtues, right? It has these virtues. So 2110 as a system kind of, you know, it achieved that objective, and you could have a whole discussion on whether it was the right objective, but that was the objective, was designed around, that's the objective it achieved. Now, subsequent to that, we've all realized, gee, there's an economy of computing as a resource that you can get in the open market from, you know, cloud providers. There's also an economy or a value to just the tool chain of virtualization. Even if you're running in your own data center, the packaging and so forth of virtualization technologies is super powerful. And so, you know, that's all good stuff, and people want to use that too, and that's great. But 2110 wasn't really designed through the lens of exploiting either of those technologies. Getting to the data center is easy when it's in your basement, and hard when it's in the out there, right?
Right.
And, you know, hard translates to expensive, whatever. But equally, the things that make a computing application work really well in a virtualization type environment are a little bit at cross purposes with some of the, you know, timing kind of things that we tend to do in the wired plant, like in the proper, you know, television plant. And so even when it's your own data center, there's things that you want to do sometimes that are below that virtualization layer. And so that's where we've, you know, that's where we honestly need to have a slightly different approach to how we separate the layers as we move parts of the production pipeline into virtualized and hosted environments. You know, you can't, like a typical SMPTE standard tries to standardize everything down to the wire. And thankfully in 2110, we stopped at IP and assumed that IP meant IP on Ethernet on wires, you know, but fundamentally, when you put stuff in a more of a hosted or virtualized environment, you have to stop somewhere in the middle at an API and then trust that the environment you're running in is going to do its part of that API in a way that might be different depending on whether it's in a hosted environment, whether it's in your data center, whether it's somewhere else.
That's exactly the no, and that's a really good framing, and it's I 100% agree with that. You know, talking about 2110, I think the byte packing part of that, essentially the thing that dictates the order in which bytes are delivered, is incredibly interoperable and importantly transferable. But to your point, when you're talking about a cloud infrastructure, which is inherently and by design multi-tenant, which means that you are competing against HTTP and TCP and all these other not noisy neighbors, you need an implementation that is designed from the ground up to not only survive, but thrive in that environment. But that doesn't mean, I think to your point, John, that we can't all agree on the top side of that coin, which is the interface. It's the byte packing order. It's the stuff that deals with the interoperability and then lets vendors like AWS, like other vendors, provide an implementation of that standard that is best suited for their environment. And that's a little bit different than 2110 because, to your point, it was prescriptive all the way down to the wire. And that, in some respects, is what keeps it, it makes it less applicable for these, as it is in its current form, for these deployments in different environments that aren't essentially, dedicated media lands. So yeah, I think that's a really good framing, and I agree entirely with it.
Well, certainly, David, from your switcher background, you've got lots of workflows in your back pocket from what you've seen over the years. So, just where you were going there, how's cloud changing that now?
I think in a way that we haven't seen before, and I'm really excited about it. Yeah, my heart has always been in production. I've always enjoyed trying to find new ways to make a production more accessible, not just to operators, but from a content perspective too, to make more content, which is what our industry is all about. And what the cloud does, I think, or virtualization in general does, and software-defined video workflows does, is it starts to unlock some of the hyperscalability, agile cost models that, frankly, companies like AWS have been selling for years, for workflows that today don't often or can't utilize them because of their dependency on high bandwidth connectivity, uncompressed connectivity. And so that is super interesting in two ways. One, I think it means we can make more content, because if we have a cost model that grows and shrinks with the complexity of a given live event that you want to produce, that generally should mean that we should be able to make more content. More content becomes commercially viable to make because cost model can be driven down to a point where it makes sense. And I think it also, for broadcasters, makes the utilization of CapEx headache disappear, or certainly mitigates it, right? Where today, if you spend millions of dollars on capital infrastructure, especially traditionally, where you're building these very expensive trucks and rolling them out to an event, you have to find a certain number of hours a week, or get a certain number of hours a week out of that infrastructure in order for it to be profitable over a prescribed, amortization period. And, switches are expensive, like on-prem switches are not cheap. And a truck isn't cheap. So I think it unlocks the ability for, I think, this kind of virtualization that we're starting to see, that unlocks the ability to have less of a headache around utilization. But I think also, and perhaps more excitingly, at least for me, is for a chance for us to think a little bit more about what cloud production means operationally. There's an opportunity here not to just lift and shift, which is saying in AWS, where essentially you take an application and you just move it into the cloud, and there's no transformation of the workflow. And clearly there are certain parts of production today that I think are good candidates for lift and shift. I think a VisRT graphics solution running in the cloud probably looks a lot like it does on-prem. But I hope, my sincere hope is, when it comes to the production switcher, that we use this opportunity to not just build a 50 ME switcher in the cloud. Like, I think we can do better, and I think that's I think with technologies like uncompressed video in these virtualized environments gives us an opportunity to, as an industry, to start to look at what that means. So that would be my view.
We'll go to 50.5 MEs. It's all about that.
Exactly.
Half an ME. Anyway, I don't want to bring up old wounds there. You've probably been through it. Let's get over to Evan here for a minute, and let's jump right to the meat. So, why do we need uncompressed in the cloud?
I wouldn't say it's a blanket statement necessarily. I would say some customers definitely want to do this, and some customers don't find much value in it. And it depends what type of customer you are. For the customer that's doing live production, well, how about this? If you need to work on the pixel data, you need to be in that space anyway. So that's one thing to know. If you are in the distribution world and you are not so worried about latency, I guess is what it comes down to in this case, then compression between instances is fine. It works great. It always has. But now we're seeing this new type of customer who's pushing us towards more real-time workflows, right? Like if you're interested in live sports, the reason that we need, especially live sports production, the reason we need uncompressed video in the cloud is because anything other than that is too slow at the moment, especially in distributed systems, right? Like if you have what David was talking about, what we don't want to do is build a gigantic instance and put it somewhere and then run old switcher software on it. I don't think anybody wants to do that. But what you might want to do is have a system that's distributed across many instances that can breathe. Who's calling me? Someone called, sorry. And by breathe, I mean it can scale, horizontally or vertical and meet the demands of the specific production that you're doing. So I think that's one thing, is flexibility. You don't have to like buy a production switcher and be stuck with that exact size of production switcher. You can spin up the thing that you need for the production that you are doing. And then, if you have this dynamic environment where essentially all these instances are sharing their frame buffers with each other, you pretty much need that to be uncompressed, because the act of compressing it and uncompressing it adds latency, and it takes your CPU. That's the word I was looking for. It takes your CPU away because you're trying to compress or decompress, 30 signals or something like that. So you don't want to eat up all your CPU budget doing that. You want to do your production. So I think that's where I'm at with it. Does that make any sense?
Well, certainly. It's about pixel manipulation and where you're going on that. One of the big things I'll let John ask this question or home in on this, but anything that we've always designed in the past, it all came down to deterministic value. We didn't care if it took 10 seconds or 10 milliseconds to do something. We needed it consistently. John, you want to kick in there?
Consistency is a virtue, but there's lots of virtues. And so if we've learned one thing in the past 7-8 months of producing television very differently, it's that the things we used to think were sacrosanct are now things we can have a conversation about, right? And so, that's good, I think, for all of us, because this whole experience, God willing, it should end one day, will change how we look at the things that are important in production. It's all about the content and what's operational and what can people do. Now, I do want to dwell on an economic point that Evan brought up a minute ago, because I think that that's really the crux of the matter. The ability to move into, IT infrastructure and scalable compute technology gives people choices, and in hosted environments, it gives people choices that are dynamic to the event. So if you have an event that needs a 12ME switcher, you can fire that up and you can pay by the minute for that switcher to do your event and cut your show, and at the end of the show, you're done. And then maybe you even plan your show differently to not need a 12ME switcher. But that's a choice that we've never had in the past. In the past, you would make a decision once 8 years ago that you bought a 12ME switcher because someone dreamed that they might need it one day. And then you're stuck with that 12ME switcher and all the things that feed it for the life of that studio. And so this shift of being able to talk about the incremental cost of a production based on the production design of that show, we've never had that before.
Right.
And I think that has kept shows from getting made, honestly, because to get made, a show had to cover the freight of the studio that was there, which was probably overbuilt because it was going to do some other thing. that economic point's huge because it changes how we think about show design, production design, everything becomes flexible now. You can pay for what you need or not. You know, you can pay for what you can not pay for what you don't need. Right.
Something like that. Anyway, that comes back to David's comment on CapEx. Go ahead, Evan.
It also enables new types of customers. I think John was hinting at it with the "some shows didn't get made" comment, but there are some customers that want to make content that haven't been customers until now. How about that? Because they've been priced out of the production switcher game the way it's been. But now, you know, anybody can do it. It's a democratization of the technology. So, you know, if you want to go produce a show, maybe you can't buy a 12ME switcher, but maybe you could, you know, rent one for a few hours and, you know, run it in the cloud. And then the other thing is just like, I'm excited about this because I think it'll save people money. I really do, because instead of buying something, like how often is a production switcher actually used? You know, working in these places, you go and you build your production switcher, you pay people to plug all the, you know, production switcher stuff in, and then you turn it on and you use it 2 hours a day, and it just sits there.
Hopefully.
Honestly, like, hopefully use it more than 2 hours a day. But I see so many control rooms that are just empty because they're not running shows out of these places 24/7, and in the cloud, that's not a problem anymore. You can.
So yeah, I think REMI has helped, right? So if you look at what we've already looked at this as a business before this health crisis, before cloud virtualization was in reach, we already started to think about how we can get better utilization by using connectivity to bring signals back to a central location, so that we can essentially bring ISO so-called camera feeds back to a location, and then have a centralized production crew, theoretically getting better utilization from capital expenditure because you're doing more with the same kit, because you don't have to drive it 400 miles, right, between events. That, I think, when you start to look at virtualized workflows and cloud-based production, it's really the natural extension of that model, right? It's saying, okay, not now. We've all got to the position where we're comfortable with centralized, production. We're not flying crews directly to every event. The next step is that we take away large parts of the capital infrastructure completely. And to your point, Evan and John, it's a pay-as-you-go model. That means more content, for sure. More content accessible to more people. And frankly, for vendors in this space, more business. Like it means I can build new products and services that I couldn't build before, that I can sell to a whole new tier of customer that I didn't address before. So I think it's exciting across the board, from broadcasters, vendors, to production companies, to the NEPs of the world. I think there's just such a huge opportunity for us to rethink the way we're buying and selling and making television.
So you talked about software-defined workflows or video workflows. So let's talk about the process. Obviously, if you've got a switcher in the cloud, you need people that run it. How's that going to work?
Yeah, so I think there's one
people on the same thing, or how are the boards going to do, or tie together? Think of the old days. What happened? One guy was there in front of the whole thing, but
right,
it wasn't necessarily good.
Yeah, well, I think this health crisis, to John's point, has kind of forced us to rethink that. Right now, we're making TV shows in our spare rooms, and that's super interesting. It's like we were all forced into a time machine and sent forward 8 years. So I think one thing that's super important, and it doesn't disappear when you migrate these workflows from an on-prem location to a virtualized environment like the cloud, you need connectivity, because these solutions are not single vendor, and I think for the foreseeable future won't be single vendor. And healthily, I think not single vendor, right? I think we kind of like that idea. And so we need to provide interoperability. So I think as much as when we talk about uncompressed in the cloud, we're all focused on the raw horsepower. Wow, we can move, 12 gigabits of data around, plus some change. That's of course important to all the things that everyone was talking about, the horizontal scaling, the more modular software design. But ultimately, I think unless we can solve the other major problem that SMPTE 2110 solves, which is interoperability between vendors, you can have all of the connectivity you want in the cloud, and it's not going to be impactful. So I think that to me looks like that's the other side of this whole discussion, which is we need to make sure that what we're bringing, when we start to talk about connectivity in the cloud, we're thinking about it from a standards-based approach, because we want the adoption, the buy-in, the shaping, the improvement from our community to make sure that we're working in a multi-vendor space and that we're all agreed that we have the right approach to do that. I think that's super important as well when we talk about these kind of uncompressed workflows running in cloud, in public clouds.
Yeah, I mean, ultimately, you keep using this word uncompressed, Stan, and you put it in the title and everything else. It's probably the least important part of the whole thing. Really, what's important is that it meets the production requirements. So some productions need really high picture quality and an ability to scale horizontally across compute infrastructure because of the workload. And that's where this particular, technologies like CDI or, this, how do you get production quality video from instance to instance, that's where that's super important. And by stepping up and creating an API for that, what AWS has done in the hosted environment is to bring this ability that as an application developer, we can call that API and say, here's frame of video, boom, and the rest of it happens in a way that's time bounded and guaranteed to work and so forth. And that's super helpful, because then, as application developers, we can focus on that. In, say, a data center environment in a basement somewhere, we could use a different technique under that same API. Right. And use the same applications, but in an environment where just the capitalization model is different. And that's important too. Now, that, whether it's uncompressed, whether it's adequately compressed, is there a benefit to using truly uncompressed versus JPEG XS on either end of that compressed? Well, it turns out there is, because when you have enough bandwidth, you don't have to burn the CPUs on either side, which, by the way, is part of your instance size. And instead, you drop the video frames onto this magic API and they show up in the other place, and it's handled in a way that you need less babysitting at the application layer. You don't have to invent your own. And B, it's just takes, you just pay for fewer cores. It's a beneficial thing, whether you're buying the CPUs on, well, I was about to say whether you buy the CPUs on Amazon or whether you host them in AWS, but it's a,
yeah.
Either way,
I think there's a tool for there's a kind of like, in my mind, there's like a right tool for the right job approach here. I think if you're a Grass Valley or you're a major switcher manufacturer and you wanting to build some kind of compositing a product in the cloud, then sure, let's use uncompressed between all the various software modules in the pipeline, because why have the headache of having to encode and decode content if you don't need to, right? Point one. But when it comes to interoperability between a switcher and a graphics, a production graphics system, or even potentially a replay solution, maybe it doesn't need to be uncompressed there. Maybe compressed is fine. And I think we don't need to be too prescriptive about that, because as long as whatever we choose is standards based. So whether it's part 22 XS for compression, or whether it's just essentially -20 or part 20 like uncompressed, I think as long as we're using standards when we're figuring out what they all look like in these new environments, we'll be golden.
So you rightly so, John, talked about the COVID thing and how people are accepting I won't say lesser quality, but different production quality, let's call it that way. And that sort of thing. And I like your comment there, David, as far as, we're in a time machine 8 years later, but I hope we're not this way 8 years from now.
No, I didn't mean health-wise.
Let's jump into your time machine and go ahead a couple of years and go from there. So where are we with regards to what type of productions would we be doing? Would we be able to do a super high-end sports production? Notice I said, well, in a couple of years, back when we're back to the full, you know, thing with the crowd and everything else, because in those instances, as you can appreciate, there's a lot of activity going on.
Yeah, I think the vision is there. In all practicality, we're not today, right? I don't think we're going to do a Super Bowl in AWS come February. I just don't. I think that we've got some work to do. But I think in investing in the connectivity story, particularly uncompressed or lightly compressed, we're taking a giant step in the right direction, and we're providing tools to our vendors who need to also like take this journey with us to realize that vision. So, you know, we walk into a PCR, there's a lot of equipment, as you point out, and not all of it today has a cloud version, right? They're for various reasons. So I think that to me is a journey that is going to take some time. But yeah, I remain confident that it's within reach in the not too distant future.
Yeah, well, that's really good to see on that side. And I guess the other question is, how do we deal with, you know, NTP and stuff like that?
Well, that's Evan's favorite topic, so I'm not going to talk about that.
Okay. That's why you were muted.
Hand grenade.
Yeah, my favorite topic is knowing what time it is. That sounds super interesting. What's the question?
On
There
NTP timing.
Just got a clock on the wall. That's all you need.
Yeah, these clocks on the wall here. You notice John and I have a match set there. So
what? But I don't know what the specific question is, other than
well, just talk about how you know the lifeblood of any facility is timing. It's like you couldn't even believe anyone could live without color black and AS11 and on and on and on. So I mean, and then of course we've gone over to you know,
I can believe that. I mean,
anyway.
Yeah. I mean, when you're in a frame buffer world and you're dealing in whole frames at a time, it makes it a lot easier because you don't have to make an electrical cut in the middle of a frame like we did in SDI. So you don't have to have it like perfectly aligned to that same degree. Like I want to do a 2x1 switch, and I want my you know, the next pixel to be the next pixel of the same frame. Like we don't have to do any of that anymore. But we have to be close. I mean, we have to. If you have instances that are moving frames of video around that are uncompressed, you should be within one frame time at least. So that's kind of the target that we've been going towards. And there's a few outlier examples where you actually do have to be more accurate than that. But for the most part, when you're talking about frame switching, we're no longer talking about an electrical or like an analog or even a digital electrical splice, as it were. You're actually, when you call for a frame change, you just, okay, fine, now I'll show the next frame that was in the frame buffer. And so, you know, that frame has to be there in time. So we start to talk a little bit more about time budgets, really, is what I've been seeing, which is I have, say I'm running in 60p land, you know, I have 16.5 milliseconds to get my frame from this instance to this instance. And the whole thing has to get there in time because that application is going to need it. Whereas in the past, it was more like, you know, the whole frame of data has to get there within the same amount of time, except that it had to be paced at exactly the right rate. And I think that's really the difference here, is that in the cloud, you don't have to pace it so specifically anymore. And it's one of the things that PTP helps with on-prem, because we're doing, you know, packet pacing, because we didn't want to blow up anybody's switches or anybody's link budgets. And so we said, you know, if I have a 10 gig link, I want to fit exactly, you know, 6 in there. I want to know that I can always fit 6 1.5 gig signals in there, and I don't want to have to worry about burstiness. And therefore, I need a clock as accurate as PTP to make my packet timing perfect. that was one use for PTP. So that specific use case for PTP vanished entirely in the cloud. We don't have to worry about it at all. But what I will say is that the frame synchronization still has to happen. So, all the instances that we know about are within 1 millisecond of, you can test this yourself, but they're within a millisecond of the GPS time. So the max skew between two instances is supposed to be 2 milliseconds. So that's well within 1 frame time. And then the outlier is, of course, we need to do audio synchronization. So that is a little trickier, but it's not that tricky. I'll pause there. Does anybody else have questions about this?
Well, I think the thing you have to remember about PTP and all this stuff, Stan, is that it's not, even on the ground, even in the 2110 world, we didn't really need PTP and all its wonderful accuracy because of the new stuff. We needed PTP and all of its wonderful accuracy because we had to hand off and interchange with the legacy plant. And the legacy plant had a lot of expectations of things being in very tiny time windows. So this, the idea that, okay, we're going to run this stuff in a data center and it's going to do a timing model, it doesn't have to be the same timing model. We're not stuck with that. So let's not stick ourselves with it, right? Mm-hmm. The whole notion of time inside a traditional television facility was like, everybody's got color black and verticals here and everything goes march, 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 clunk, 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 and it's all perfectly lined up because I could still make color black out of it and I could still run those into them, not really, but you almost could still. Now, we have the opportunity to take that one noose off the neck and put it in the closet forever and say, look, we're instead going to say, I'm going to go through a pipeline of things, and the timing of relative signals only matters at the points they meet. So yeah, if I take video and audio apart and send audio to the sound desk and 12 different cameras into the switcher, then the switcher's got to line up the cameras. The audio desk has to line up the audio signals because it's going to mix them. And then later it all comes together at the end and there's time tags that help it line up again. It's keeping track of the time of the content that matters, because that's ultimately when you mix things in the vision mixer, as the British call it, or you mix things in the sound desk, that's the time that matters. It's the time of the content.
Yep.
Now, there's also, again, at some point, maybe that signal re-enters a traditional plant. It has to get synced back up to the traditional plant. Okay, we got ways to do that. But that's almost the outlier in the new model, right? It's send it off and pull it back and time it in. Okay, great. We got that. That's easy enough.
I agree.
But we have to have a different way of keeping track of time inside the virtual workflow, and that involves the time of the content, not the time on the wall.
Yep, I agree with that. I'll add specifically, some people say, I need PTP in the, I've heard this question before, I need PTP in the cloud because I need to synchronize my cameras. My answer to that is, that doesn't make any, your cameras are not in the cloud. Your cameras are over there. Synchronize your cameras, timestamp them, right? Like make sure all the frames have the right timestamp coming out of the cameras, and then that's your timestamp. Now you know you can have something in the cloud like a switcher, to your point, John, and the switcher's job is to line it up. But at that point, it's easy. It doesn't need PTP. All it needs to do is line up the frames with the right timestamp together. And that's really a simple problem.
I think it's a great opportunity to get rid of non-integer frame rates as well.
Whoa, don't open up.
That's just crazy talk.
Too soon? Too soon, obviously.
We'll do everything at 72 hertz.
And they were, too soon,
Yeah, we've only been out of analog for, it's not long enough, right?
Let's not get into that. I don't even think when you fast forward 8 years, we're going to get rid of 1,001. Anyway, let's stick with 5994. Well, we're probably on something here that's 20 frames a second or whatever, so it's all relative. So I think that comes down to the point of quality and stuff like that. And as far as needing PTP in the cloud, to get your cameras. It's obviously timestamped on the Essence, so move on and things like that. This does beg one question though that I haven't figured out yet. And whether you're in the cloud or not in the cloud, this has been a big issue. Everybody is having this tremendous fight for low latency. And it's just absolutely amazes me. I can watch something on my satellite feed and, it has nothing to do with the satellite delay. It's, it's seconds late because of all the compression stuff and everything, backhauls in and out and everything else. That's the issue. And then, and people haven't complained for years, but now as soon as we're getting on mobile devices, people instantly want this low latency thing. So how does that fit? Is that real? Is that needed? Or is that only the very few conditions that are needed?
I think the problem is not so much, there obviously, like, everyone likes the idea of watching sports as close to it actually happening on the field, right? I think that's just a general desire that probably hasn't changed an awful lot. What has changed is the fact that there's a heterogeneous delivery process now. Head end is both OTT and primary screen. And what I think people really hate is hearing their neighbors cheer for a particular thing that's happened on their field that's still 25, 30 seconds behind on a different feed. That we have to fix, because that is going to create a really unsatisfactory customer experience. If I'm watching a particular sporting event and my neighbors erupt in cheering because something's happened in their version of this game that I'm not seeing for another 25 seconds, that's a problem. So I think the consistency across the heterogeneous nature of converged, multiple head ends like that is super important. And so low latency, I think, when you look at the shift in the OTT industry towards low latency, what they're really trying to do is get it down to and within reach of what we would call broadcast latencies of, a couple of seconds, 5 seconds, not the 25, 35 plus seconds you've seen traditionally with OTT delivery of content.
Well, I'm going to jump in there. They're trying to get down to a second. It's just, at this point, that's what the push is.
And I think then you have to start to wonder if sending tiny files through a CDN is the right approach. Right? I think maybe you've got to start looking at true streaming technologies like WebRTC. I think when you want to go below a second, are we really going to make that work with traditional CDN delivery of content? I don't know.
I have found that 1 second is aggressive. I haven't found anybody said, give me a second. I've heard what you said, give me the same as I had before. I've heard give me better than I had before, but not in terms of synchronization, more in terms of like betting.
Gaming is a big one, right? Yeah.
It's funny.
Betting is obviously the thing, yeah.
Like there is this triangle, and the points of the triangle are the cost of the system, the latency of the system, and the reliability of the system. And you can sort of stretch it in any direction you want. Like you can have super low latency, like you can blast UDP packets over the internet directly from a stadium, and you can get that feed over the internet way faster than through the broadcast chain. What you give up is reliability, and that's expensive, but it works. You can do that. And you might want to do that if you have a betting application, because maybe that's it. Maybe it's you forego all the fanciness of the production, you put a camera on the field, and you let people bet on what's going to happen, and you just get them that video as quickly as possible to have more opportunities for that. And that could be the experience, and that's different than the broadcast experience, which is, give me all the bells and whistles, give me the commentators, give me the graphics, So I would say different cases here.
I do think bringing production into the cloud, though, definitely helps in live events, at least, with the overall latency story. And I think having technology that doesn't require mezzanine encoding between various connected pieces adds to that, right? Generally is working towards the lowest possible latencies if you're not encoding. I'm sure, like if you're talking about technologies like XS, of course, the amount of latency codec like that adds to a pipeline is minimal anyway. It's frames, less than a frame in each direction probably. But it all adds up. So I think by moving content closer to your head end, particularly if your head end is also running in a virtualized cloud environment, that's going to only improve the overall glass-to-glass, so-called glass-to-glass latency of a live event.
Yeah, before John jumps in here, John, I'm just going to remind people we've got a chat box here, so if you've got some questions, now's the time to jump in. Go ahead, John.
You really got to think about, there's two different latencies that people talk about, and they're vastly different orders of magnitude, right? So you just brought up distribution latency from, finished show to when do I see it and when do you see it, and when does the person who's watching it over the air sees it. There's some who still do, versus somebody who's watching it, local and local over a satellite provider. That's an interesting 2 satellite hop thing. And that's all one kind of latency. And yeah, there's some applications and betting and things that are very sensitive to that. But there's another latency that I think matters more to the production side of the thing, which is really the human interaction latency of the production professionals. Because you have to remember, we're all technology people, but this is a creative process. And these are content creators who are cutting a show, and the rhythm of the show and the rhythm of the cuts matters a lot. And it's what makes the difference between good television and bad television sometimes, is that creative rhythm of it, and that the cut happens at the right time relative to the ball hitting, and all these things that the production professionals are really good at. And we're messing with their mojo by sticking extra delay in there. And they're sensitive to it, and it's part of what makes good television. So the other latency that I'm talking about is really that human interaction latency of how does the human perceive the switcher, the feel, this or that. And so when we first started rolling out like playout environments in originally basement hosted, then data center hosted, and now more cloud hosted, there was a lot of worry about that interaction, particularly master control operators who are, it's a live sports thing, but they've got to drop in commercials by hand and things. They were very concerned about it.
Music too. Music's another one where that's really important.
Right, and so, we started looking at the current environment, say how much latency is there in a master control suite in a typical TV environment? And guess what? Everything has a frame buffer in it already. And there were 7 or 8 or 9 frames of latency, even in a typical MCR suite. So then we said, okay, well, can we take some of those and turn it into J2K ultra low latency and this and that? And we got it in the same zone. And the operators would work in one room one day and another room the next day. And they'd say, they're different, but they're not meaningfully different. You get used to it 3 minutes in, and you're just, you auto-calibrate within a fairly narrow window. Now, you can't make it seconds like that. That'll never.
No, agreed. Yeah, I'm a big online gamer. I like playing video games, and I recently signed up for a service by another cloud provider that essentially renders the games in the cloud. So all you get is a controller and a little thing that sits in the back of your TV. And when you express control, that control signal is sent to a cloud resource. It renders, in this case, it's a video game. It renders an entire frame of video based on that control input, and then encodes it and delivers it back in the compressed domain to a device sitting on an HDMI port in your TV where it's decompressed, uncompressed, and then sent to a screen. And then you're dealing with the inherent latency in the television screen itself. And that's usable. And it's not only usable, it's imperceivable, in my view, to running a local rendering. So I feel like we've come such a long way in solving that control latency and lag in recent years. It's become with these incredibly efficient codecs that are designed for that. XS being, of course, a clear winner in that space. I think we can do so much more than we could even 5 years ago.
Evan's dog wants to say something.
Yeah.
Oh, my dog hit the thing and now it unmuted. I'm sorry, guys.
Not to worry. Anyway, no, valid point. And when you look at the Cloud example you were just doing with gaming, and as well as getting into production in the cloud and everything else, that opens up the whole AR, VR world totally.
Esports, that's just so interesting, right? Where we're not even dealing with optical cameras anymore. Now, someone like me gets disappointed about that, but at the same time, I think there's a real potential in that. where production is actually built out of entirely virtualized sources too. Yeah, it's interesting.
Yeah, and another positive attribute, by the way, of all these technologies we're talking about is none of them care that the picture is 1920 by 1080, right? And particularly you get into VR, you say, what's the pixels and what's the it's like, who knows? It depends how it's set up today, right? And that axis of liberalization, none of these devices have screens that are any of the geometries that we currently force every piece of content to be in.
Yeah, I'm a proponent of any new standards that we work on together as an industry. We shouldn't have these rectangular frame size limitations anymore at all. We should allow the application to describe what shape it's trying to make.
Mm-hmm.
Yeah, I think that's spot on. Right.
Yeah, and I as the more we work in these new things, I think one of the, if there's going to be an enduring legacy that comes out of 2110-20, it isn't the timing spec of every packet has to go a certain way. It's the nomenclature we came up with across a large variety of segments of the television production industry around words to describe the pixels. How do we describe pixel aspect ratio? How do we signal the colorimetry and the HDR and all those things? That nomenclature will probably survive the other aspects of 2110-20 because it's the only one I know that's a mutually agreed list that covers the whole swath of use cases.
John, can I ask you a question? 2110-23 describes a method for allowing your essence to be broken up into even smaller essences and reconstructed. Do you know of any applications or vendors or customers that are using that particular part? Because I also thought that was interesting, that we said we're going to allow this to happen, to not move down one wire anymore, that we can have multiple senders and receivers that can all participate in something to construct a frame together. It's collaborative frame construction, if you will. But I haven't actually seen that done in practice.
Yeah, a generalized mechanism to achieve what you're describing probably would have been really cool, but I think that particular RP was really designed around a super specific use case of I want to do UHD, but I didn't spring for the 25 gig ports on the switch.
Got it.
And
yeah.
The more the generalized thing you're describing of saying maybe I make like a what they call it, use one of the wavelet codecs and decimate and recombine and have different versions that are usable. That's a really cool thing, and that we can do today with JPEG 2000 or with JPEG XS. That's the beauty of these wavelet codecs.
The other thing that I was thinking you could do with it is, it enables parallel computing, that's for sure. Like I get the UHD thing, it's kind of similar to the 1080p thing we did years ago, which was we did a quad split and you couldn't tell where the boundary was. It's fine, but you could break up your picture into many, many smaller instances and send just parts of it. And this little teeny process is responsible for that little postage stamp, and this one is responsible for that postage stamp. And you could probably build a whole multi-viewer without actually having a multi-viewer that way, and just having the receiver, respect the way that 2110 is supposed to work and say, okay, fine, I don't care, I got these pixels from different places.
You can, although it's not a spatial decomposition. It's really a spatial.
You're trying to do an object store on there. That's interesting. All right. Well, we need to.
Okay.
Yeah, we need to wrap up here because of the. We'll have more Q&A and we can chat after in the after party as well there. So I think, this has been a real interesting, cool topic. We've covered a lot of stuff from David got right to the heart of it. First time you spoke, you mentioned CapEx. So you got right to the meat of the cloud, which is great. And that's what it's all about. And the rental houses over the years have been doing well. And that's exactly why, because people wanted to rent something just for production. And even if they paid for it 1,000 times over, it didn't matter. you could have the billing and you kept their CFOs happy and kept budget on that sort of thing. I like the way we covered software-defined video workflows. David reminded us about audio a couple of times, not enough, but we do need to think about those different aspects. And it was a good way that talking about the pixel world versus compressed, non-compressed, where we're sitting in that. So a good go today. So with that, I'm going to turn it back over to Jack, and he can dump us in our own time machine for the after party.
Hey, thanks everybody for joining.